Hello, everyone. Good morning, good afternoon, and good evening. Thank you for joining us at Light It Up 2.1 and for today's discussion of what's next in street lighting standards. My name is Jordan Wainwright. I'm an integrated marketing analyst with TE Connectivity, and today I'll be going over a couple housekeeping items before introducing our presenters. All lines will be muted during today's session, and during the audience Q&A at the end of the session, we will be fielding questions which can be submitted using the toolbar seen on your screen. Those questions that we are unable to get to today will be answered in a follow-up email with a link to the recording. Without further ado, I'd like to introduce Jonathan Ketchpole, TE Systems Architect, and Dave Dentonier, Secretary General of the Zhaga Consortium, as they begin our discussion today.
Hello, thank you, Jordan. As Jordan said, I'm Jonathan Catchpole. I'm a system architect at TE Connectivity and Vice Chair of the Zhaga Book 18 Working Group. Today, I'm joined by Dave Dentonier, the Secretary General of the Zhaga Consortia, an alliance of companies creating specifications for the lighting industry. In the webinar, we will be talking about the role standards play in street lighting, specifically Zhaga's Book 18 and what's coming in the new release. At TE, we believe the future of street lighting is controls, due to trends driving the market, energy savings, and the continued discussions around smart cities. The industry's accepted number for the amount of energy spent powering streetlights is 30% of a municipality's energy budget. Albeit an oversimplification, the displayed graph shows the progress of those savings. First, switching from incandescent light sources to LED, then adding controls to create part night and dimming profiles give further energy savings. Though controls don't need to be limited to turning the light on and off, cost savings can be made in other areas of a municipality's budget. For example, sensors that ensure rubbish bins are only emptied when full. We have seen more technology go into streetlights in the last 10 years than compared to the previous 6 decades. As the graph on the previous slide showed, this starts with changing the light source to LED. But it's not a simple step progression. There are 300 million installed luminaires globally, growing to 350 million by 2025. And by 2025, there will still be 200 million left to update to LED. Currently, there are 2 different infrastructures in place. Permanently powered, like we have here in the UK and the US. In this case, each street light needs a control device. These take different forms, but are typically a photo control device, like the image on the right-hand side, which is a pluggable photocell. Therefore, the luminaire and photocell can be purchased separately and installed together on site. In the UK, all street lights are unmetered. Therefore, billing is done by tariffs. But for some states in the US, energy metering is done in the pluggable photocell itself. These need to be periodically removed from the luminaire to be calibrated. Mainland Europe typically has group switching. This is where photo control device is mounted to a feed-in pillar or a control cabinet and switches a group of luminaires. The issue with group switching is it's difficult to dim the lights and get those extra energy savings. So here we are now seeing trends towards individual controls. For example, the Antwerp Ring Road and the UK Highways Agency have installed controls on each light, moving away from group switching. I'll now pass over to Dave, who will take us through the timeline of the Book 18 developments.
Thank you, John. And indeed, I'm Dave Dentonier, Secretary General of Zhaga. And Zhaga, as John explained, is an industry consortium with about 300 members from the lighting industry. Our mission is to create interface specifications for components of LED luminaires. And the aim of this is to enable multi-vendor ecosystems of interoperable products, making sure that products from different vendors work well together. And we also run a certification program to create trust in this interoperability. Well, before kicking off on Zhaga Book 18, Let me first take the opportunity to thank TE Connectivity for all its contributions to Zhaga. And definitely, this cannot be done better than in a webcast on Zhaga Book 18, to which TE Connectivity made many contributions. It's also well illustrated by the fact that John is the vice chair of the working group developing this Book 18. So thanks, John. Thanks, TE Connectivity, for that. Now, Zhaga Book 18 plays on the strand towards individual controls that John just discussed. It defines the interface between a luminaire and a node, such as a lighting controller or a sensor. And the interface is defined so that it enables multi-vendor interoperability between nodes and luminaires from different vendors. Indeed, this sense of interoperability didn't came to us in one go. It took us several steps to get there, and these steps, these stages are illustrated in this timeline here. So in the first stage, and that ran approximately until end of 2018, we developed the mechanical interface of the luminaire, and the so-called Zhaga socket. And during this process of creating Book 18 Edition 1, we realized that a mechanical fit only would not suffice for plug-and-play interoperability. Additionally, we needed to define also the electrical and communication aspects of the interface. And the driving vision for this has been something for like a USB slot. Indeed, a USB slot on a computer can be used to extend the capabilities of a PC. We envisioned the Zhaga interface to do the same, but then in a way appropriate to outdoor lighting, using the Zhaga slot. And to achieve this plug-and-play interoperability, we teamed up with the DALI Alliance, a standards organization, and we understand that it's important not to reinvent every wheel ourselves. DALI is by origin a fairly general wired networking protocol, much used in the lighting world. Its original generality does not make it fit for plug-and-play interoperability. Therefore, the DALI Alliance started working on a plug-and-play intraluminaire variant of its networking protocol. And this variant is now called the D4I protocol. As soon as this work was finished, we could release edition 2 of Zhaga Book 18. It defines a two-node luminaire architecture and the use of the D4I communication protocol. It also included the Zhaga D4I certification program for nodes and luminaires, and this task was completed in November 2019. We were then alerted by the market to some additional needs. As John also explained, some geographies have a preference for lighting controllers focused on on-off metering. The need is to keep this approach and still benefit from the features of the Zhaga Book 18 Edition 1 interface. And therefore, Zhaga is again making an update of its Book 18 specification. This will give luminaire OEMs an additional option. The extension also specified hybrid luminaires that have an ANSI C13641 interface in conjunction with the Zhaga interface. The advantages that a luminaire OEM may also use existing lighting controllers focused on on-off metering and still offer innovative features such as environmental sensing and area security monitoring to luminaires. And the extension is so that it still meets the Zhaga interoperability promise. And we have progressed well with this specification and expect edition 3 defining the hybrid architecture with an ANSI C136.41 interface to be ratified mid-April next week during our upcoming members meeting. And so, John, this completes my somewhat historical account of the Zhaga editions. Handing back to you for more about the technology, I trust.
Thanks, Dee. As they said, edition 1 of Book 18 defined the mechanical system for an alternative interconnection platform to the ANSI interface. The ANSI interface has been around for about 80 years, and although it was updated 7 or 8 years ago to incorporate signal contacts for dimming controls, it was designed for incandescent light sources. That is, it is large with large contacts, plated with gold, designed for high power applications. The new Zhaga interface has been created with LED lighting at its core and takes advantage of the new generation of drivers coming to the market. These drivers incorporate, amongst others, 24-volt auxiliary power supply and a powered DALI bus, which is used to power the control devices that can be plugged into the interface. This means that mains power isn't connected through the interface, making it much more compact and in turn gives better ingress protection and the ability to be mounted facing in any direction. At Zhaga, we have defined both sides of the mating interface and a group of tests that must be passed. Coupled with the certification program, the receptacles, node-based plates, and sealing caps can all carry the Zhaga Z, showing that they comply with this specification. At TE, for the Zhaga interface, we have our LumaWise Endurance S product range. This is made up of the receptacle shown on the left. We will soon be releasing our Gen 2 version of that product, featuring dual wire poke-in, an updated seal for certain mounting configurations, and a unique locking washer for a featureless plain mounting hole. This receptacle is for Zhaga applications that use the D4I protocol. But where people have different applications or a proprietary communication protocol, we have a keyed version. This is so we keep the Zhaga architecture clean and ensure the promise of interoperability. We also supply sealing caps, bases, and domes in different sizes. The bases and domes make up the enclosures that our customers use to manufacture control devices. As Day described, in November 2019, we released edition 2 of Book 18. This update to the book drove the 2-node architecture that can be seen on the screen. We can now have 2 control devices on the same bus, typically a photocell or a communication node on the top of the luminaire and a sensor input device on the bottom, like a motion sensor. At Zhaga, with this edition, we went beyond a mechanical fit system to the promise of interoperability, meaning different manufacturers can produce different parts of the system, be that a driver, luminaire, photocell, communication or sensor input node, and they will all work together. As Day said, Zhaga did this by creating a liaison with the DALI Alliance, the owners of the DALI protocol. Now, DALI 2 is a multi-master protocol, but doesn't have any hierarchy built into it. So whichever control device speaks last on the bus, the driver will react to it. This is a condition that could not be allowed to exist in street lighting. Therefore, at the heart of this solution is the D4I protocol. It takes care of this hierarchy issue and is the only protocol that is allowed, which is controlled through a certification program. All parts of the system can now be certified. Drivers are certified and marked D4I by the DALI Alliance, which 8 different manufacturers have already done and can be found on the DALI Alliance website. Luminaires are being certified by Zhaga and marked Zhaga D4I. Control devices will also be marked Zhaga D4I, though this program has only just been released. They will discuss the Zhaga D4I certification program later in this presentation. This specification defines the simplified wiring architecture, having both interfaces connected to the same communication bus, the use of the D4I protocol, and the allowed power budgets for the control devices. Both interfaces are also connected to the same 24-volt DC power rail. Therefore, control devices can be powered from either the internal auxiliary supply or from the DALI bus power supply. but this is defined in detail in the specification. The results of this specifies a robust and simple way of specifying different parts of the solution. I'll now pass back to Dave, who will take us through the Zhaga certification program.
Yep, up to certification. Essential to our approach is that nodes and luminaires from different vendors work well together. Multi-vendor interoperability is key. Therefore, we have developed a certification program to test and certify luminaires as well as nodes. In conjunction, we have a trademark and logo program that allows the use of protected trademarks for certified products as a sign of interoperability. And Zhaga D4I certification can be gained for luminaires as well as nodes. And the flow diagrams shown on this slide show the steps needed to get the certification. On the left, you see the certification process for luminaires that luminaires need go to. And typically, luminaires will comprise D4I certified drivers and Zhaga certified receptacles. And this allows for a really easy certification process. Luminaire OEMs need be Zhaga member. They need submit information about the luminaire system diagrams and letter of conformity to the test house, and then the test house will validate this information, and after this upload the information to the Zhaga database with which the certification process is completed. The certification process for the nodes is a two-step process, basically because there is no node component pendant of the driver. So in this case, the control node or the sensor has to be submitted for D4I certification. And for this, the node manufacturer must be a DALI member. After this process has been completed, the certification continues at Zhaga, for which the node manufacturer has to be a Zhaga member. Again, he will typically submit information about D4I compliance, about the use of a Zhaga certified baseplate, and some more architectural information to the Zhaga test house. After this, the Zhaga test house uploads the information to the Zhaga database, which completes the certification process. And the Zhaga D4I certification processes were so designed that they are really easy to do. The luminaire need contain Zhaga certified receptacle and D4I certified drivers. And next, it's a paperwork exercise. Moreover, it's possible to certify luminaire families. And this is really important as outdoor luminaire families are typically characterized by very many configurations. Next slide, John. So after having completed the mechanics of the certification process, it's also important to zoom in on the benefits. Zhaga D4I certification really gives benefits to the industry. First of all, it gives confidence for interoperability. Certification is carried out by independent authority. Certified products are traceable in public databases, and certification logos are trademarked to prevent misuse. Certification gives business advantages. Certified luminaires and components are available from multiple suppliers, and certification logos provide an established brand for product marketing. Certification ensures that luminaires are future-proof and will be able to host next generation of Zhaga D4I nodes. Certification also makes for an easy specification process. It is a good tool to indicate that the products are part of the ecosystem. It is then, in our firm belief, important to do the certification, and that it is a great way to drive volume and scale for connected outdoor lighting. And we are also delighted to see the great uptake in the market, both in terms of product availability and the market demand. By now, 19 manufacturers provide certified luminaires and have in total certified close to 100 luminaire families. And in fact, the numbers are increasing rapidly, with a good influx of new members with an interest to certify luminaires in Zhaga. And in fact, it's going so fast that they can hardly keep up and maintain an up-to-date picture of companies certifying products. So here we only see the initial 16 companies certifying the luminaires, but the Zhaga website always gives an up-to-date picture of certified luminaires and luminaire families. And as said, the development was enabled by a strong ecosystem of DeFi drivers and Zhaga receptacles and a simple certification process. Also from the specification side, we see good uptake and Zhaga D4I certification being in high demand in tendering projects for outdoor lighting. So it's a great success already. And I would say that with the upcoming edition 3 of Book 18, we are well on track to make it an even greater success. And with those words, handing back to you, John, for more on Book 18 edition 3, I believe, and possibly more market information, indeed.
Thanks, Dave. Up until now, we've been talking about an alternative interconnection platform to the ANSI interface. The ANSI interface is only standardized in the North American market. As this slide shows, it's the de facto standard in almost every other part of the world. At Zhaga, we have recognized this market need and are liaising with ANSI to release an update to Book 18, which will allow for a Zhaga ANSI hybrid architecture. Edition 3 of the book will allow for either a single Zhaga interface, 2 Zhaga interfaces, or a single upwards-facing ANSI and a downwards-facing Zhaga interface. Again, with this architecture, both receptacles and the drivers will be connected to the communication bus and the 24-volt rail. The control devices will be powered from either the DALI bus power supply or from the auxiliary power supply. Also, the driver will be permanently powered. This architecture has the advantage of being able to still have energy metering in the control device, which, as I said, is a requirement in many states in the US. The hybrid architecture won't compromise on the promise of interoperability, but will now give specifiers the flexibility to specify an architecture that meets the regulations and standards of their region. For the ANSI interface, at TE, we have our LumaWise Endurance N or dimming receptacles. We have the standard 5 or 7 pole dimming receptacle, as well as the rotatable versions for north-facing photocells, even having a toolless version. Again, we have bases and covers in different sizes and colors, as well as a range of shorting caps with and without surge protection and open circuit shorting caps. Lastly, I'd like to thank you for your attendance today, and I'd like to thank Dave for his contribution to the webinar. In closing, before we go to questions, I'd just like to recognise that we are now on the start of an exciting journey for street lighting, with technology advancing more in the last decade than the previous 6. And with the Zhaga D4I products certification program promising to be the backbone of smart cities. Here at TE, we are able to support our customers with our strong market knowledge and our market-leading street lighting portfolio. I'll now hand back to Jordan for questions.
Thank you, Jonathan. Thank you, Day. I'm just going to open it up for questions now. So we see a couple coming in the chat. So first, for Jonathan, do the clear covers protect the enclosed circuit from UV degradation?
Yes, that's right. So we mold our covers from UV stabilized material, and that also provides some blocking of UV radiation.
Okay. So next question coming in. So with the high demand for certifications, do you know what the expected lead time for node certification is?
Well, that would be down to the Zhaga test houses. So you'd need to contact one of the Zhaga test houses to inform you of lead time.
Okay. And then another one for you, Jonathan. So why would you need a shorting cap for the NEMA C136.41 and not for the Zhaga interface? Perhaps you might have answered that, but just another question for you.
You're drifting away from your microphone, Jordan.
Oh, sorry about that. So why would you need a shorting cap for the NEMA C136.41 and not for the Zhaga interface?
So this is to power the driver. So in a ANSI or a NEMA architecture, the power is routed up through the node. In the Zhaga architecture, the driver is permanently connected to the mains voltage, so you don't need a shorting cap in that case.
Okay. Another question that came in, so can you use a 0-10 volt in a Zhaga Book 18 luminaire?
That's a 0 to 10 volt. No, so that's in Book 18, we only allow for the D4I, the digital protocol. This is for interoperability reasons, and this is so that we can have greater control than an analog control signal would allow for.
Okay. So a question for Day now. So do you have to be a Zhaga member to certify a luminaire?
Hey, thanks for the question. Yes, that is indeed, I can be very brief here. That is indeed the case. So Zhaga certification is open to Zhaga associate and regular members.
Okay.
Thank you.
Sure. And so another question, and I think this might connect with the second one that was asked. So do you know when we can expect to see control nodes on the market for the Zhaga G4I certification?
Dave, do you want to?
May I take that, Jonathan?
Yes, please.
Although I'm sorry, I cannot yet make the big announcement, but yes, we would expect that any day now. So we're sort of tuning the certification process. You know, it's a collaboration between organizations. It is fine now, and I would expect the first certifications to happen any day. Thank you.
Another one for you, Jonathan. So in the Zhaga and ANSI hybrid solution, can you power the 24 volt DC bus from the control device?
Yeah, it's an interesting question. I believe that ANSI will allow for this configuration, but the Zhaga, to keep its promise of interoperability, the 24 volt bus will need to be powered from within the luminaire, either from an auxiliary power supply, a separate auxiliary power supply, or one built into the driver.
Okay. And then another question for you, Jonathan. So are all of TE's products certified?
Yes, absolutely. So depending on what product range, they're certified for Zhaga applications or for ANSI, with ANSI certified, as well as UL and IEC, and all of our certifications for all of our products can be found on our product website.
Okay. Then another question for Day. So how would you know that the communication protocol your luminaire control device is using?
Hi, yeah. Of course, we talk about two communication protocols here. One internally, so the intraluminaire communication protocol, and the one is the protocol communicating externally from the luminaire to another luminaire, or from the luminaire to a central management system. If your protocol is Zhaga, if your node is Zhaga D4I certified, then you know that for the intraluminaire bus, so internally, the node is using the D4I communication protocol. It doesn't say anything about the external communication, the wireless communication, or what kind of sensor you have. That is free, and that underlines the flexibility of the architecture. But internally, it's D4I, and that's what the Zhaga D4I certification guarantees.
Okay. So we had another question come in for the Zhaga Book 18. It looks like the edition 3. It says, do both the D4i LED driver and the ANSI node deliver 24 VDC auxiliary power?
Yes, so for it to be compliant with the Zhaga D4i certification, the nodes have to run off the 24-volt rail, and the D4i drivers typically have the 24-volt auxiliary power supply built into them.
Okay. Okay. We got another question that said, does the Zhaga socket work principle is similar to the NEMA socket?
There's quite some market differences. So the NEMA receptacle had been designed, like I said in the presentation, so it had been designed for power applications. So it's been designed to have mains or grid power routed through the receptacle into the node, and then can be switched back to the driver or the load. The Zhaga receptacle has been designed specifically for LED lighting and specifically to take into account low power requirements. So in this case, we only have signals being communicated via the Zhaga interface, and these are signals from a node, which could be a photocell, instructing the driver what to do. So there's some quite large differences between the two products.
Let's see if we have any additional questions in here. Okay. All right. Well, I think that about wraps it up for the questions. So thank you, Jonathan. Thank you, Dave, for your time today. And thank you, everyone in attendance, for your time today as well. I think this was a really great session, and I look forward to connecting with you over Light It Up.
Lovely. Thank you very much.
Thank you very much. Looking forward to talk again soon. Bye-bye.